Okay. So welcome back to the end-to-end deployment workshop. So for this one, is it not sharing? Oh, okay. So yeah. I'm Pat and with me is Tian Cheng. We are the same presenters. Okay. Um. So what we covered in part one was that we deploy a React app on Kafka workers and explain how the difference between local host and the internet and how that deployment works, right? So today we'll be building on top of that. So here's what we're covering today. First, testing. We'll make sure that your app will work every time you write a new code or write changes to your code base. And this will be the same test for the color swipe app from part one. Then for so CD will be instead of manually running pm deploy every time, you set it up so that when you push to GitHub, it automatically runs your test and deploys for you. Then after that, Tianchen will go through containers. So that's Docker if you prefer that, and how to package your app so that it runs in the same way everywhere. And then monitoring it so that we know when things break in production because things will break and it's better if you know when they break, right? So let's get started with testing. So why do we write tests? Manually kicking around the app every time you change something, that's not like scale. And real test, every change is a gamble, and you fix a bug in the voting logic, or accidentally break the resource page and only find out when someone tries the app. Of course, you can find this out manually, but sometimes you'll be doing so many changes that you cannot actually tell in your manual testing. And so that's when the um like the means that if you try to debug everything, you can actually run into more issues. And with tests, you turn the different checks into code. So green means the behavior we care about still works, and red means we work on track and we have to start looking somewhere for like the issues, right? So so this is the testing pyramid. There's at the bottom here, there's unit testing. So these are the bread and butter of testing, and there's a lot, and they test one function at a time. So like, does this function return the correct URL? And you can usually have 100 or like 1,000 of unit tests in one code base because they're like super easy to write, right? Then in the middle, integration testing. This test will typically test multiple things. So for example, whether your server based connection is working, or if you're connected to an external service like say OpenAI, that connection is still working in your application. Then at the very top, these are like the holy grail of testing, end-to-end testing. So this system that I will use there, they will open a browser, log in, click buttons, start swiping cards, and basically they'll simulate what a real user will do on your application. So that way you can catch out anything. And yeah, so okay, like I said, unit tests are the smallest one. They test one function. So whether or not, say for example, when you open this red SVG, does it return the red SVG? So does it return the correct value? Integration testing will test a few things. So for example, if we hit the endpoint API colors, does it return the mock server base and mock API, mock database, etc. If this is true, then good. Our connection still works. Our main API and routes still working. Then end-to-end testing is basically the full flow. If the full flow works, then that means okay, our user can continue using our app and we can deploy to production. If it doesn't, we have to figure out why it's not working in, for example, a staging environment or a QA environment, right? And like as an example, right, this is a unit test. So what we do here is we import the like testing framework, which will be using VTest, which is a testing framework from the CPU speed. They're a popular modeler and they just got bought out by Cloudflare the other day. So yeah. Um, but the more important thing is that to do a unit test, there's no browser, no server, no database. Every input should be giving the same output. So if you do one plus one, describe one plus one as your unit test, then it should be returning one plus one from the image URL from the expect here. And it will be describing your test. Yeah. And usually these unit tests are like 1 or 2 milliseconds, so you can run 1,000 of them at once. Yeah. Okay, then for integration testing, we are testing a lot of things at once. So for example, your super base, we want to create a mock database so that way, um, we really create a mock database, super base current that we can have a fake table, and that table will be wrapped with fake data, synthetic data that is like from an sample user or like sample database. And but because we're connecting to a database, this will be a lot slower. But the important thing is that this will take an external service, so Superbase, OpenAI, Google, Amazon, any service that you connect to, it's good to have an integration test so that way when you do deploy, you know, or like you do changes to anything actually. For example, if I'm doing a test, I change to the logic for how a leaderboard works. Sure, it may not hit the OpenAI endpoint, but I may be changing something somewhere, and we should still be testing that. Oh, when I push these changes in, it will actually still work on that OpenAI endpoint, right? So yeah, this is why we fake external services so that way it's a very foolproof way of knowing that your changes will still not break anything. Yeah, and for the bottom part here, there's this is basically just making sure that okay, your database was created a mock database properly, and the mock database is equal to what we expect, and then we can start testing the database tables. So, okay, we know that the table exists, and the database, the table entries are correct. Yeah, and here's end-to-end testing. We will it will basically open the app through a framework called PaidRight. PaidRight. If I remember, it's a framework by Microsoft. And especially, okay, sometimes you can do it headless, where there's no UI, but sometimes you can also do it without headless, so that you just basically describe, okay, I want to load the page, so you go to the entry point, then you basically wait for the HTML to load this dot card um, element, right? So then after that, once you've done this, you will be asking it to know that, oh, this is visible. Is it visible? Is it not? Yeah. So yeah. Then after that, you can actually grab the bounding box. So okay, if you're familiar with HTML and JavaScript, you can do DOM select element select ID by ID, right? So to select an element on your HTML page. What we can do here is Playwright will simulate a browser for you, usually Chromium, but you can do Firefox, Safari also, I think, so that you can cover all your user browsers, right? But for the most part, most people just run Chrome and call it a day. Yeah. Um, but yeah, this will actually simulate, and you can simulate mouse movement. So you can simulate clicking, simulate drag up, drag down, drag left, drag right, that drag right. So you're basically simulating a full user, and that's the main like thing is the main trade-off. Like the browser test here will be slower than unit test or integration testing. And when they fail, you will have to screenshot or like try to trace the test path so that you can locate it on your local machine or like on the staging environment. But the important thing is that if this fails, you know for sure that your user will fail. Yeah. So the staging environment will be using is for VTest. It will run all your stuff directly. It will run TypeScript directly as well. And it's a framework built for Vite projects, but you can also use it for non-Vite projects on the web or like a backend server written in JavaScript. Yeah. And the most importantly is like super fast. It's running the same like core as Vite, where most of it is written in Rust, and so being that it will be pretty fast, right? And another thing is that okay, before Vitess, there used to be called this framework called Jest by Facebook, if I remember. Jest is a bit slower, but the important thing about Vitess is that it runs the same um, compatible API as Jest. So if you are following a tutorial for Jest, it will work roughly pretty much the same. You can swap out Jest for Vitess and you will work the same. Yeah. So this is the first thing we'll be doing. So I have a test file. So okay, so this is the test file, right? In here, you can basically see there's a few. So we have made a new directory for um, the like this part two, right? So if you have pulled the repository before, you will have to open the repository on GitHub on your GitHub. Then there's this thing called like this branch is 38 commits behind. Okay, and because we just push changes to the main repository that you fork from, you can basically sync fork so that this will update your branch to the latest of what we have on the main repository here that you forked from before. Yeah. Then from there, if you open your project, you see that there's a part one, part two, and of course the slides got updated. But in part two, there's a new folder called apps. Web is our classified app from part one, and web search is what Chinchon will go on later in the workshop about Docker and containers, so that you can deploy a Docker app, right? But for my one, I will be focusing on app, and here there's a few things. Um, API is your integration testing. Thailand is your unit test, and end-to-end is your playwright test. Yeah. So to like explain a bit more, this is your um test for to like okay, so starting from the imports, um before each describe it and expect are the testing framework of VTest and V as well. V is the way to call a tester. And we import app directly from worker, the worker file here. This one. Yeah. Okay. Um, and the mock select mock order mock from functions that will basically model the tool-based chain used by the route later on. And this means that okay, so tool-based has a basically a way to mock the client, right? So we can basically mock creating a new client for tool-based here. And then down here, these two are basically routes that we want to try and test, right? That okay, so once we hit effect health, it returns okay and expect to be 200 and the JSON that we return for API slash help should be the same as well. Then API colors means that when we run API colors, it should return the same format, same table, and same rows as the server base that we mock from. Yeah. So this is the API in here. Yeah, that's a few more rows, but yeah. So then what we can do here is okay. Um, so we can run pm test API. So this okay, we ignore the fee error. Um, but basically you can see that how once we hit the endpoint worker.test.ts, this will run the test for our API and our integration, right? So for example, health, okay, it returns okay, status service name. Sentry and we ignore for now. API colors, we basically got the same colors from server base and returns empty when server base is not configured. Yeah, which is correct, right? Because this is what we expect it to do. But if you for example, if we remove something like the super base mock current, right? Yeah. Basically, this test will fail, and this will basically point to you that oh, the super base connection is not working, and we know that it's not working because we didn't get the correct color return from the mock testing framework. Yeah. So this is a really good way to know that oh you can't expect the API to work 100%. But what you can do is make sure that 100% of the time you are notified when the API is not working, right? So next we'll do the unit test, which is like pretty simple actually. Like before, we import the same stuff from VTest, then we import a few of the API. So in here, okay, I can't scroll. We can see describe like what we expect from the UI, from the test to do. And it's same as before. We image the test that we want to describe, then a description, some variables, what we expect it to be, and that's it. If this all pass, then good. It's pretty much a unit test. Yeah. So uh test yeah, I mean it's a simple current. We launch the API, we do this and we test that how it works. Yeah. Then for playwright, this will be a bit more like complicated, right? So what we want to do is we launch the like playwright instance first, and we have to download this, right? So you run pm execute playwright install, and you install Chromium usually. Usually people will do Chromium, not Firefox, not Safari, but it's useful to do both Safari and Firefox as well because otherwise those platforms have different web capability. So yeah, then we run end-to-end tests and yeah. Usually that's a way to often like how to view the worker. But I forgot how to do it. Oh, Okay, I think I forgot to set up my token. Okay, but anyways, I can go through the playwright test, but basically, it will basically um go to the route that you want to test. Therefore, whether or not this selector exists, then we can if it if like all the okay the elements were dead, then after that we can basically test whether or not the the elements we want are loaded or not, right? And this will basically grab us the bounding box for the card that we want to swipe, and we'll just swipe. Yeah. Okay. Um. Okay. So for like let's take a break for like 3 minutes, then we'll go into CCD. But basically, same as before, we basically please make sure that like you um fork the repo and it's up to date to the main branch. Because we'll be working on this one to deploy our own actions like this. Yep. Okay, so CCD. What's this CCD? So like I'll go briefly like a bit on this. So uh oh, okay, so you in part one you deploy manually, right? So you run GMT deploy after you finish coding, and uh you remember to run test like maybe like after doing all the testing just now, and you run GMT deploy manually. And at some point you will forget to either run test or run deployment, right? So and that's like okay for if you're working alone or like you're working with another person for like Orbital, for example. But in a big organizations or in a big project, ideally two and three should never be skipped, right? And that's the main thing with manual deployment is that you have to remember all this and you have to remember that oh it's working properly. And more importantly, you need to remember to have the credentials working. Yeah. And CI/CD moves those steps into a repeatable pipeline. The machine runs the same command every time, and in a clean environment, it will basically like consistently deploy that, right? So what is CI? CI stands for continuous integration. The idea is pretty simple. Every time you push code to GitHub, it automatically picks up, run your tests, install your dependencies, and if everything passes, like we said, mark. If something fails, you still rate X, right? And so what does it matter? The continuous part means that it happens on every push, not when you remember to do it. So let's say you're working on your Orbital project at 1 a.m. or like 4 a.m., 5 a.m., right? And you push some code, you actually broke something, your CI, your CI pipeline, you actually test it immediately, and you can fix it instead of like forgetting to run your test or forgetting to deploy. And this is important because like maybe like a week later you have a demo, you don't want to be failing the test before that demo, right? Yeah. So then that's CD. What's CD? CD is continuous deployment. So for that situation, you basically test your code, right? To make sure that it always works, always integrates properly. Continuous deployment will automatically deploy after every push and after your test will pass. So you push code, your test pass, you deploy automatically, and it's now live in production. So what does it matter? Um, every time you just can just write code anytime, anywhere. And as long as you push the code to your repository online, it will deploy and it will always deploy in the same manner as before. And you don't have to remember to your deployment steps. You don't need to remember your secrets, your API keys, etc. That's also continuous delivery, but that's for something else that other teams do. Yeah. But that was more for you need someone else permission to approve. So for example, my manager will approve the deployment, but I can't approve my own deployment, right? So today we'll be using a workflow tool called GitHub Actions. GitHub built in a CI/CD platform and with no extra tools to install, unless you want to test your CI/CD pipeline locally, right? But ideally, you should be testing that it works on GitHub so that way, oh, you know the feature if you run this test, it will work. But usually, you can run both locally and online. Just that's a sanity check, right? It doesn't have to run more tests. So GitHub Actions is part of your GitHub. Is inside here, this tab, and here you can actually run all your previous workflow tests, workflow runs. Yeah. And the concepts are pretty simple. A workflow is a Java flow, yet another uh, markup language in the GitHub trash workflows, and that defines the pipeline. A job is a set of steps that runs on a fresh virtual machine. So it's like a clean computer every time, nothing from your laptop. And a step is a single command like run pm test, and a trigger is what kicks off the workflow. So when you push in or when you merge something into your main, this is how it will run. So let's look at like what our workflow is currently looking like. So here's the workflow file. It's a bit big, but you go slowly. Name is your workflow file name, like describing what it does. And on is basically it will only run on when you push to the main branch and when you have pull request to push into the main branch. Yeah. So there's two jobs here. One is test and one is deploy. Okay. Uh, oh, I just opened the workflow. Okay, in GitHub is gonna be in the GitHub workflow, and maybe in here, for example. Yeah, okay, so there's two jobs, test and deploy, right? So the test job, you check out the code from your working directory, so apps/web. Then the steps will basically describe what you are trying to do. So you will set up pnpm, set up node, and yeah, action set checkout is GitHub zone commands for running stuff, right? And with node, it will run the cache pnpm and the dependency, so pnpm log, which is a constant file that you should be committing. So that way, if is okay, okay, pnpm log is a file that okay. So you have package.json, right? Which is your dependencies. Package log or pnpm log. For Node, it will be package slash dash log.json. For pnpm, it's pm dash log, right? This is a way, so that way, if you run clean install or clean install of your packages, it will install the same dependencies as what the developer used locally. And if you are collaborating with other people, PPM log will log your dependencies versions to the same ones across everyone, no matter who runs your repository, for example. Yeah. Then next you run your test, run playwright and end-to-end test. Yeah. So, oh no. Okay. Uh, okay. This is the workflow file. So to explain a bit more, there's a few blanks here, right? Run test is not playwright, run end-to-end test. So I'll be grabbing it from here, but it's basically roughly the same as before. From what I explained, right? So PMPM test will test the whole unit test. Test end-to-end will test the playwright, and playwright install will install your dependencies. Yeah. Then after that, deploy is to basically configure your deployment. And okay, this GitHub ref means that it will refer to the main branch and will run on Ubuntu, the virtual machine. And it will work on this directory and it will basically do these steps. So we'll do first. It will check out, then it will set up PFPM, set up node. Then based on the PFPM log, it will install your dependencies and run deploy. Run
Mhm.
deploy will run regular deploy, the same as before, right? But I mean, because now it's in CI/CD pipeline, it means that no matter what, you will be able to continuously deploy this no matter what. And here we'll declare a few secrets, your Cloudflare API token, so that it can deploy on Cloudflare, your Superbase URL and Superbase key, so that it can create the mock database. Same as here as well. Yeah. So your phone needs credentials to deploy and run tests, right? Things like Cloudflare API token, Superbase URL, and key. And because you should never put this in your code, like before we said to put on them on Wrangler secrets, is the same as here. You should be putting your secrets on somewhere so that it's managed by someone else that you trust. Someone else that you know that will keep your secrets encrypted and not leak them, right? So keep actions such as secret feature. So you go to your fork on repo on GitHub, your fork repository on GitHub, go to settings, secrets, variables, and actions, and put in a new secret. So in here, oops, oh, secret variables. I couldn't see. Oops. Okay. Here you can basically add in a new secrets here. And yeah, it's the same as before. You go to server base, you grab your keys, URL, reusable key, and put it in. Yeah. So for example, I'll copy it in. Um, so in here, you go to your Kafka dashboard and create a new token, edit workers, edit Kafka workers, set up end date so that way it doesn't consistently like run forever. And choose your account. Usually you only have one, and uh, your zone is basically your domain. Which one you have access to? Yeah. Then create this token. Then copy this and save this somewhere because you will not be able to get this again unless you create the token again. Yeah. Then that's the secret. Add it into Cloudflare, add it to GitHub, and this will basically be able to every action can access this secret. But yeah, then you do the same for Superbase URL and Superbase key. This URL. Yeah, Superbase key. Okay, so this done, right? So now what we have to um this is the scary one, right? You basically will finish up your test, commit it in, then push it into main. So for example, uh oops, okay, yeah. um, okay, so when you have your repository here, you go into your test and you fix up no, no your test. Oops, that's wrong. In okay, basically fix up this code your workflow, right? So that way from here we can actually um, deploy it into GitHub and it will run our test. Um, so basically, you configure your workflow, right? Then once you're done, you create a random commit message, update CI/CD workflow, thing changes, and this will send your commit to your history, right? Oh, sorry, my workflow full. Oh, oh. Um,
Have you checked the triggers for the workflow? It's probably,
Oops, yeah.
yeah, that's right.
Okay.
Yeah.
Uh,
So in this
yeah.
case, what happened is that these workflows will only run on certain triggers. So there are certain triggers that can set. So for example, here you can set it so that when you push any commits to main, or when you have a pull request that merges to main, or a pull request to main, we can run these CI workflows. There's also a manual workflow trigger, like workflow dispatch that allows us to trigger it manually. Uh, but yeah, if you do face some bug where like your flow is not running, you can check the workflow triggers.
Yeah, so in your actions, right, you can see all your actions test workflows. So for our when colors for CI/CD, so our CI/CD workflow is our commit, and because we push the main, it will be triggered, and yeah, you can view the test job, and this is all the dependencies installing in order. So running the test, right? Okay, we ignore Sentry. It will run worker test and API test, both of which went through fine. So integration and your unit test. Yeah. End to end failed because so like for example, right, you can tell that it failed because it couldn't open the card and it couldn't find the card. So you have to fix this and yeah. So test failed. Then deployment, you can rerun okay because okay just to show that deployment can work. Oh,
Yeah. So the reason why in
push.
this case, right, deployment doesn't work is because there's actually a dependency
Yeah.
in the workflow. So you can think of the workflow kind of like a directed graph, right, in which we can define dependency. So I can say that, hey, if my main test fail, I don't want it to deploy, right? Because let's say something in the app is broken, right? So I don't want the app to deploy. So I will make the deploy step depend on the testing step succeeding. Yeah.
Yeah, but okay, basically, with deployment, you can basically, I can show it in the main cycles one, but so this running Kinopec test is another way to deploy your stuff, right? Yeah, it will basically run your deployment and deploy onto your correct endpoint so that you can open it and just deploy courtesy. Okay. Um, so this is like just the start. So, oh, my slide's not updated. Okay. Okay, so this is the start. There's still a lot more. And what we covered today was writing tests, run tests, use TI to stop broken code from deploying, like just now. And but real tests will grow extra machinery around that loop. So pictures and factories help you create global test data. We will copying giant objects everywhere. This is like more like enterprise or like production level, like if you are interning somewhere. And then accessibility testing, like for example, whether or not your site is accessible for visually impaired people. So when they use the screen reader, your site layout will still load for them fine. Yeah. And then there's visual test, so like visual regression and contrast testing. So that way, you can basically see that your app is visually still the same. Yeah. And coverage testing will basically tell you that, oh, whether or not your code is fully covered. And if it's fully covered, that's usually a good thing, but it doesn't have to be fully covered all the time. And yeah. Then 74 CI/CD, it will today we edit a basic pipeline. So run on push, pull request, install dependencies, run your test, then deploy only after test pass, then store credentials as well. But in proper projects, you will require checks before merge, have a preview deployment per PR, and then staging in production environment so that way you have a production like setup. So with like some mock user data, some proper deploy APIs, and so when you do staging and production environments, usually you have the actual data not as a mock, but as a proper database that they can hit the endpoint properly. Yeah. Then manual approvals for risky deployments. So when you have a PR, you can actually approve the deployment if the test like even fails, right? And rollbacks. So that way, if you have a deployment, you can roll back the deployment if the deployment you just did was wrong or like was faulty or created an issue. Yeah. And do artifacts and caches mean you can basically have an artifact and it will be the same thing every time, but you don't have to rebuild. Yeah. So where to spend effort first, your test your critical path for your overall project. Most likely is like what would be the most important thing to test your API endpoints or like your unit testing for your backend, and then you start from there. All right. Then test boundaries. Test whether your app talks to other services, so database storage, AI, payment, email, for example. These three all work, and no matter what, it should be tested. Yeah. Then automate your checks. It's only useful if you run your test, so automate so that if you push to a PR before your teammate approves the PR, you'll be run. And do not try to build a huge like enterprise process for your Orbital project because that's a really big scope. Build a small one, start small, and you just grow your test suite fantastically. Oh, whoop. Okay. And most importantly, a broader like mental model for CSCD, right? First, is it correct? Your test type checks, linting, maybe even like security scans if you want, but usually Orbital don't have that. And whether or not you can ship this, so your builds, your environment config, your deploy credentials, what changed, your commits, your release notes, your artifacts, version tags, and what can we recover? So your rollbacks, alerts, and monitoring. And this one is mostly for the later part of the workshop. So yeah, this yeah, I'll pass it to Tiansheng to talk about containers and observability.
Okay, I'll go ahead and share my screen. Let's see. There we go.
Yep.
Okay, you can see it. Uh, I'm just tweaking. I got this. Okay, excellent. Okay, so hi, I'm Tian Cheng, like from last week. So I'll be covering this part on containers, and afterwards we'll be covering on how to add some monitoring and like telemetry to your app. Now, I want like to take you back on a recap back to last week, where we were talking about the different ways in which you could deploy your application. And if you recall from last week, we deployed our app through what we would call like serverless functions, right? Where we have the code. So we have like our code base and we just run like Wrangler deploy and that uploads our React and Hono app to a Cloudflare worker and that hosts our app. But I also mentioned in last week's slide that there are other ways of deploying your applications and they kind of depend on your need. And one of the ways that we mentioned that you could deploy your application are what we call containers, right? And this is what we're going to be covering a bit more deeply into today. So let's start. Okay, so let's try and understand. Sorry, my God. Let me give me a moment. All right, let's see. All right. There. Okay, so let's try and understand what problem like a container is sort of trying to solve. So some of you might have experienced, like let's say you're working on Orbital team where the code works like perfectly on the machine. Let's say, you have a teammate, right? You're running on like a MacBook or a Windows machine and you have some sort of code. Let's say you have some backend that's running, let's say fast API or something like that, right? So you run the code on your machine and hey, the whole app works fine, right? But then you push your code, because you added some new feature, whatever. But let's say you have your teammate, your Orbital teammate, and he pulls your code and then he runs and it's like, yo, I'm facing like some error. So in this case, like let's say you had some library, like I don't know, OpenCV or something like that you install, but your teammate is on a different environment and he has some trouble like running your code, and like you have to fix all the dependency issues because you're on different environments. And even worse, like this is like still something that you can still resolve between the two of you. But what if, let's say, you go ahead and you deploy your application. So, like in the base case, maybe you deploy on a like Cloudflare worker like Python instance, or you deploy on like a VM, right? You went on like AWS EC2, you go and like provision a VM and then like Ubuntu VM, and then you deploy there. But then like when you push your code and then you pull it, you find that on deploy, you face some bug, right? And this is a classic problem in software development where you know the code works on your machine, but it only works on your machine, right? Because on other people's machine or on the deployment environment, they might have some missing system dependency, different version of Python, different OS even, right? So containers are a sort of way of trying to solve this problem where you say if it works on your machine, then why don't we just ship everything that's sort of on your machine? So the idea is that instead of just shipping your code, instead of just deploying only your code, right, to wherever you want, we are going to package everything. We're going to package your code. We are going to say that, okay, run it on like, if you're running your code, like let's say Ubuntu, we're going to package an Ubuntu instance. If you have certain libraries, let's say you have some features that users like, let's say OpenCV or FFmpeg or some certain dependency that you definitely want to be there. And you might even want a specific version, right? Because let's say you have some dependency where like it only works on this older version of Python, for example, right? And you need to make sure that on every environment you deploy it to, or even like your teammates, right? They are running the exact same version of Python, like whatever exact library and everything, to reduce the sort of like debugging effort where, if it breaks in production, right? You can at least rule out that, oh, it's not the case where you have the wrong Python version or something like that. And it's actually just a problem with your code. So the idea being that if a container runs just perfectly fine on your laptop, it should run the same way in production. So, okay, that sounds fine. But last week we were talking about, serverless function, like serverless paradigm where we just deploy your app onto Cloudflare workers. And that seemed to work just fine, right? Like, is there a need for containers? So I would say that it's not a thing where like a serverless function like a Cloudflare worker or Firebase functions is objectively better than a container. They have different pros and cons, and it really boils down to how much control you have over the code. So in these sort of managed platforms like Cloudflare Worker, the platform basically handles all the infra, like handles the scaling and the dependencies for you. But because of that, you have less control over uh your code. So what it means is that, let's say for Cloudflare Worker, they only allow you to use currently it's like you can have a Node.js, right? So you can have like your React app, you could have your whole API, whatever. And they have like in beta like Python and I think Rust now and Go. But there are certain restrictions. So for example, if you want to use some like really like obscure like language, or you want to do something that is not like this typical stack, uh these platforms don't support it. And they might even restrict, let's say even if you use Python, for example, they may sometimes even restrict like the way in which you must organize your code, the way in which you set up your dependencies, like your Python dependencies, or what like frameworks they actually support. And they impose all of these restrictions because they want to sort of solve the in a way solve like the it works on your machine problem by basically forcing your code and your like local development environment to conform to what they require, right? But that can be a problem when you are building more complex applications where you need certain dependencies or you need certain languages that just can't be supported on a serverless function, right? So containers give you more control. They allow you to decide like what specific like distro or like what specific version of Python or like what specific libraries, what scripts you need to run beforehand. You have more control over this kind of stuff. And it's also in a way easier to test because if you test your code locally, let's say you run your unit test locally, it's going to run like the same way in production because you're basically just like packaging everything. You can think of it sort of like a virtual machine, but not exactly. I think I have a appendix slide that if we have time, I can go through, clarify a bit more on like how this differs from a virtual machine, if you're familiar with what that is. But all right, let's go into like some of the context. So let's say, right, we have our color side app, but nowadays, like every modern like B2C SaaS or whatever needs some AI features, right? So let's say I want to add in some like complicated AI feature. Actually, not really, because basically we're gonna try and see build like some sort of feature where I can like type in some sentence, right? I can type in like ocean or whatever, and I can find like the color that best vibes with your text. And okay, to be frank, like you could just like implement this on like Cloudflare workers if you just like call like OpenAI API or whatever. But because like we are resume maxing or something, we are going to try and implement this with some like Python microservice and we're going to call like some self-hosted model, right? So it's just like a fixed scenario. So question one, can we just do it on workers? Because I mentioned that well now workers has like Python support, but it's like in beta. One problem for let's say in this case, if I'm running like the model locally, uh, if we look at the restrictions for Cloudflare workers, uh, it's actually kind of bad. Like for a normal app, it's perfectly fine, but if you're running such a model, you are probably going to need more than 128 megabytes of memory, and the request time, I mean, it's 10 milliseconds is a bit restrictive, right? So let's say I want them to deploy on like on Cloudflare Worker. Instead of Cloudflare Worker, we're going to deploy a container on some sort of platform like Render or Google Cloud Run. In this like workshop, we're just going to deploy on Render. I'll explain a bit more later, but uh, if I have time, I can also show like how Cloud Run works as well. So basically, we're going to be building a new like microservice that our whole node API can call later, which is like a fast API microservice that just calls like an embedding model, like to find like the color that's like most semantically similar to like whatever text you type in, basically. So first of all, like let's explain Docker. So we mentioned like containers, right? So and usually when people talk about containers, you also hear the term like Docker like come along with it. And that's because Docker is one of the most common tools for building and running containers. It's not the only tool, but it's the one that is basically the industry standard, right? So some terminology here. So a container is sort of an instance of an image. So an image is something that we define as basically you can think of like a class. It basically defines like, okay, what's the underlying like distro, what are the underlying dependencies, what's like the code that's going to be run, what are the files that are packaged inside. So I mean, if you came from like 2030, which I presume you probably have done before, you can sort of think of it like a class, right? I define the class, I define the instructions of like what it stores and everything. And we build the image, right? And when we run, we can use Docker to then create containers, which you can think of it like instantiating an object, like instantiating a class, right? Uh, which is a running instance of an image. And I'll go through later on how we define an image, and then like how we run. But let's sort of like explain. So you might notice in the setup instructions on Canvas, we told you like, if you're on Windows, you install like Docker Desktop, like on Mac, I recommend like Upstack or whatever. So there's a whole Docker ecosystem. So like, although we say like Docker, there are like a whole bunch of layers to it, which I'll try and explain in like a relatively like easy to understand way. So at the bottom of the stack, we have what we call the OCR format. This is basically the standard that was actually set with with Docker by Docker. So like Docker contributed this open source format to define how the format of a container, right? This standard image format. And this is something that like even if you use another app, let's say you use if you're on Linux or whatever and you use alternative Docker called Podman, or you use like Kubernetes or whatever container, they all use like support this underlying open container format, open container image format. And then we have the engine. So in this case, we will be using Docker engine. And this is like the underlying code that actually builds images and actually like starts the containers. But there are also alternatives to Docker engine, like for example, Podman on Linux. But of course, this is something that is happening underneath the hood. So how do you actually like communicate? How do you send commands to Docker to tell it to build an image or to run something? We have CLI too, so the Docker CLI, which we will be like exploring a bit later, which allows us to send commands to the underlying Docker engine. My God. Uh, Underlying Docker engine. Uh, but if you're not really like comfortable using the CLI, that's where we also have the desktop app. So I'm getting like spam call right now. Forgive me. Okay. I'm so sorry. I got like my sister just spam calling me just now. Okay. Right. So the Docker desktop and op stack. So if you're on Mac, for example, the instructions would be to install this thing called opstack, which I'm just gonna like bring down here. Yeah, opstack, which provides like a CLI tool that allows us to run like many of the Docker commands, but unfortunately like not all of them. But it allows us to do things like start and stop containers and all that. Uh, yeah. Okay. So this is the overall Docker system. So I'm hoping that you have at least installed Docker Desktop and Obstack beforehand, because just installing Obstack or Docker Desktop will basically like set up everything else. So you don't need to install like Docker Engine or like Docker CLI. Just installing like either Desktop or Obstack will provide all the things that you require for this workshop. And like there are a bit of nuances. Like if you're on Linux, you don't need Docker that's not an obstacle. You can just install Docker Engine directly, and that provides a CLI. But let's not overcomplicate the thing. And oh my God, damn. Okay, I need to not do that. Sorry, I keep accidentally pressing the command that sort of like auto scrolls through everything. Uh, let's see. Yeah. Okay. Right. And for registry, we'll cover later. But basically, you can think of it like, okay, we have these images, but we also want a way to publish the images that we create. And you can think of it like, for example, like npm or uh like when you learn like a pip install or whatever, you pull from like the Python like package repository and all that. So basically a registry is just a place where people can actually share and like store images, and we can pull images from these registries like Docker Hub or GitHub Container Registry. Okay, so let's start. So I assume that you have Docker installed. If not, then I can just kind of watch me like run the commands. So we have, if everything's installed, you would have this Docker command that you can actually run. And you'll see like in the help page, you have like a bunch of like commands that we can run, but we're just going to test that we can run a container first. So there's this hello world container that we can run. So like, uh, I can run like hello world. I'm going to run this pull command, uh, to basically make sure that we have the image. And yeah, we have the image. So we pull this from Docker Hub registry, right? So once I go ahead and Docker run hello world, you will see that what happens here is that we run the container, and the container has a command which basically just like prints out this whole like message from Docker, and it tells you like what it did, right? So we put the hello world image, we created a new container from that image, and it runs a program that executes outputs and it exits, right? So what I mean is that I ran this thing and the thing is no longer running. So like if I were to go to run this command called docker ps, it will show all the currently running containers, and you notice that nothing is running, even though we just even though we just type in docker run hello world. So what happens is that when it's sort of like executing a program, like if I execute a Python script that just prints hello world, after like it prints hello world or something, it's just going to immediately exit, right? So this is not something that is long running as of yet, right? Uh, so it just runs and gets output, but this at least shows that Docker is installed in the system. But okay, so let's explore a bit more as to what Docker can do. So we can go ahead and pull an image, which is a Python image. So this is a command here. So this command here, so we say docker run, right? So we're telling Docker, we're going to run an image. And the name of this image is Python, and then you see this colon. So after this colon is what we call a tag. So I can have multiple versions of a Python image, and they can have different tags. So in this case, right, the tag here would be 3.12. This is a version of Python. So I'm saying that, okay, I'm going to run 3.12. And this Python image is built on top. So actually, if you think of it like Docker images, sort of like classes and objects and all that, right? You can sort of say that I can do inheritance. So I can say that when this Docker image was built for Python, it inherited from a previous image, which we call a base image. And this base image is a Debian image. So it runs the Debian Linux distro, and specifically like the version of Debian that was codenamed like Trixie, which I think is like I think it's like the latest long-term support version. And this is the slim image, which means that they remove certain dependencies to make the size of the image smaller. So, all right, so then this is the name of the image. Then the next thing we have is the command. So just now we ran like hello world by itself, and that runs as a default command. But if I add in something else afterwards, so let's say this starts a Python image by itself, right? I can type like bash, and this is the command to run once I load up the container, what command to run afterwards. But if I just do this, right, and I don't have this, if I just don't have this, I just run, you notice that nothing happens, right? And what I can do is that, I, okay, And if I don't give any command, like nothing also happens. Uh, so what happens is that, as I mentioned before, if there's really like nothing to run, or like it's just a one-time script, right? The container will immediately exit after I run. But what I want to do is I actually want to go inside the container and like sort of show off like a bit more as to like what the inside of the container looks like. So I'm going to add this tag. So this is a flag that we add to the command. This is basically interactive. Okay, so if I run this, this will actually let me go inside. It will start a bash shell. Sorry. Uh, Let me see. This should work. Oh, okay. I know why. Yeah. Okay, so the order of the flag matters. Because what happened is that if I have the flag first, uh, it doesn't know that I'm doing the Docker run command. It thinks I'm just running Docker with an IT flag. So it got confused. Okay. So let me go inside clear. So now what happens is that I'm actually inside the container. So this is what the inside the container looks like. And as I mentioned before, this is actually built on top of a Debian Linux instance. So like the file system here will be like what you would expect for Debian. So I can go here, home or that. And obviously this is a Python image. So I do have Python, and as you can see, it is Python like 3.12, right? And I can like, okay, I can print hello world, right? It works. And I can say that, okay, let me try and like create a file, right? So I'm gonna like, uh, I'm gonna do this like in a really hacky way because there is so bare bones that there's no like text editor inside. Uh, but okay, let's say I have a hello.py, right? And I created a file called hello.py, and I'm gonna run it. And okay, it prints hello world, right? The thing about containers is that once you exit the container, it doesn't persist the content. So it's all like a snapshot of what the container was like when you initially created it. So although we created a file here, if I were to exit the and basically shuts down the container, if I were to start again, uh and I go to home, you'll notice that the file we created previously doesn't exist. So containers are ephemeral, which means that they don't persist data. So if you have an app that's running a Docker container, and let's say you use like a database that is like a SQL database that's saved in the file, right? And you like constantly update the thing, the data in the database that is running in that container won't persist, right? Once I restart the container, all the data will be lost. And okay, that sounds really bad, right? But there are going to be ways for us to actually mitigate this, which we will sort of go through later on. And but yeah, okay. So we've seen what like a Docker container is like, and I mentioned it's sort of like OP, right? Where you can inherit from like some inherit from a previously created image, and then you sort of layer your own modifications on top, right? So to build a Docker image, we have to define instructions of how to do it. And we do it in what we call a Docker file, where the format is basically instruction. So like you have certain instructions and then you have arguments. And how it works is we start from a base image. So for example, here, let's say I have this Go server, right? I will build from a base image. In this case, a Golang server that's running Alpine Linux, right? And so this is something that you can find on like Docker, however. And this instruction that will be like in like your code base. So you have it in your repository, right? And you are providing Docker engine the instructions for how to create the image. So, and each instruction is a separate layer, right? So basically each command will create like a snapshot of what the container looks like after I run this command. After I, for example, run this command called copy, which will basically copy the code, for example. It'll copy the code from your code base to the Docker container. Or let's say I run another command called run. So like for example, this will be to download the dependencies and build everything, right? And each command that is run will create a layer. And the reason why there is layers is basically just for like efficiency. So the idea being that let's say if I make a change to the code base, right? I don't have to redo the previous step. I can sort of load from a previous the save state slightly before the step that was changed, and then just run from there instead of having to rebuild everything each time. Unfortunately, there are like a shit ton of Docker commands, so I can't go through like all of the Docker file instructions, uh, aside from like the really common ones. But basically important ones are form. So let's take a look at our Docker file actually. So the Docker file for the app we're building for Vibe Search is a Python fast API application. So the first thing we had to decide is what's our base image, right? So in this case, we decided that we're going to use like a Python, and because Python image, and because like uh I'm using UV to do dependency uh management for Python, I'm going to pull from this UV image, right? And let me sort of show what the code looks like to better explain the structure. Yeah. Okay. So in our apps vibe search, we have our main app and we have like the dependency and everything. So the main thing we have is our Docker file, right? So I'm saying I'm pulling from this particular image and I have to set the word directory. So I'm going to build like from this directory, right? And I set the working directory. So actually, if you have like the like I think like Docker extension installed in your code editor, you can hover over and you can get instructions. So you can see like in this case, I'm going to set the working directory to a app folder. And what I'm going to do is that I'm going to copy over first the requirements. So this can be your requirements.txt, or in this case, your PyProject.tml, which basically defines the dependencies for your application, right? And I'll copy over this. Then the next layer is to execute a command. And I'm going to run the command to basically install the dependencies. And afterwards, I will copy over like the rest of the code, right? So I'll copy over like all the Python files into the container. Then the next thing is I would say that, okay, this container needs to expose port 8000 because I'm going to run the application on port 8000. So it needs to be able to accept incoming requests that are coming in from port 8000. And then the final thing would be a command. So there are like two ways. There's like what you call an entry point, but there's also like a CMD. CMD is like a bit easier to use, but basically it's the command that's going to be run when you start the container itself, right? So in this case, I'm going to just say, okay, we're going to run like the fast API app basically. Okay, so what we're going to do then is that we have this Docker file that's actually defined, right? But we need to build it. So how is it going to work? Well, basically, I'm going to go to the terminal and I'm going to show you how you can build from the terminal. I'll also show like how you can build it from within VS Code using the VS Code extension in case you're not really comfortable with doing it from the terminal. But I'm a terminal guy myself. So first of all, I'm going to cd into the directory that has our Docker file, right? So I have this Docker file. And what I'm going to do is that I'm just going to run like uh the command. So let me just check to be sure. Yeah, Docker build /t. So /t here is actually going to be what we call a tag. Basically, uh the tag is the name of our image. So I'm going to call this color vibe search. And I can also do things, I can do versioning. So I can do at this colon, I can say like, oh, 0.1, for example. So I can say it's version 0.1 of the container. So I can sort of like version control or like define different tags so I can revert to an older version if I need, right? But let's just make it simple. And then what I'm going to do is I'm going to like define the directory build form. So by default, right, it's going to look for a Docker file, a file called Docker file. And I just press like dot, and this refers to my current directory. So it's going to build based on the Docker file that it finds in this current directory. Of course, if I wanted to, there's an additional flag that I can add. It will select which specific Docker file I want to run from in case I have multiple Docker files. But I'm just going to run this, and you'll see that it builds. And you notice that a lot of it is cached. So I mentioned that each command, right, will create like a read-only copy so that if I only made small amount of changes, I don't have to like rebuild the whole thing. I can just rebuild from the point where things change. So in this case, cache the dependencies and everything before because I already built the image beforehand, right? And the only thing that changed was the code, right? So it will just load the cache version after I did install dependencies and then just copy over the code from there. Okay, so that's my Docker build, right? The next thing I can do is I can do Docker run. So I can do Docker run, and I'm going to do this slash p flag, which is going to basically do port forwarding so that I can access it. Docker run is color by search. And now this app is actually available on port 8000. So if I were to go to, let me just go to bring up my browser, and you will see that the fast API instance is actually up on port 8000. So I'm going to go like docs over here, and you see that I can like call like uh the thing and all that. So that's the way to actually build and run Docker container. And I mentioned I'm going to show you like very quickly like how you can do it on VS Code. So if you're not familiar with like command line, you can install there's a container tools or like Docker extension on VS Code. And this is like the official one, right? And I can do things, I can take a look at this Docker file and I can right click and I can click on build image and you tell me like to name or whatever, like hello our tag. And this will basically like do everything like that we did on the command line. And I can also run. So if I go to like this containers tab on VS Code, for example, it will show me like all the containers that are running, and I can like stop and start, or I can like select that image and I can like run or I can do all this. So if you don't like the command line, this is like an alternative way of managing your Docker instances. Okay, so let me just head back to the slides. Okay, so the container started very quickly, but I'm going to show like sort of like what happens when we run a command, when we call an API within this. Okay, so let me just bring in here, and I can right click, I can view logs, and this will show me like what is currently happening within the container itself, basically. So let me check. You see like the Docker logs and stuff. You can like this is the actual commands running under the hood, right? So if I were to send a request, send API request, I execute, you will see that the logs actually update. I have an API here, which is the vibe search API, and I'm just gonna send like a query to it. So I'm gonna say uh like blood or something. I don't know. Right. And I'm gonna send a request. And you will notice that, wow, this takes like super long. And then you see in the logs, you're sending unauthenticated requests to the Hugging Face Hub or whatever, and then it's doing something. And what is happening is this, is that in this code base, we have an AI model that is like being loaded in, right? And because we didn't bake the model into the container, right? The first time we run the request, the code is going to try and download the model. And it takes a while to download the model before finally answer my request, right? And but this means on subsequent requests, it's going to execute like way faster because I have to download the model, right? And this is like part of what we can call cold start. There are other things that are part of cold starts, which are more related to deployment and like auto scaling. But in this case, we are lazily loading the model, which means that the first inference pays like the model cost because the model hasn't been baked into the image, right? So the question is that, well, what options? Because this may not be optimal, right? This sort of like lazy loading, maybe like for like the beginning, it's okay. But the thing is that you're going to be deploying this on platforms that they're going to do auto scaling. They're going to be like, only when I get the first request from user, I'm going to spin up a new version of the container. And you don't want it to be a case where you have to re-download the model every time people send requests to you because the uh deployment like infrastructure kept scaling up and down your instance. So there are different ways. So like what we're going to do in this workshop, we're going to just bake it in. Right? I'm just going to show you like how you can sort of bake in your model into the image. But the pro is that it's like very predictable and like it's so-called easier to do. The problem is that it makes your image bigger. In our case, it doesn't matter because our image is like our model is like super small. I think it's like only like 100 MB or so. So it's not very big. But if you're running like some really large model, this is not like the way to go unless you want your Docker image to be like 20 GB or something like that, which is not what you want. In that case, like if you're really trying to run like a super big model, right? You might want to consider alternate approaches. One is for certain um like platforms, you can have like persistent volume. So I can load my model in some persistent volume or something that's mounted to the container. So I don't have to re-download it. It's more of just accessing like a local like storage or like more centrally located, right? But that assumes that your platform that you're deploying on supports this and it needs like more configuration. The final option is like you can just call it API, so you can outsource it, right? You can make your image like smaller if you, let's say, instead of calling like an embedding model, you just go ahead and locally you just go ahead and call an API and let like some other person settle like how to like host the model consistently for you, right? But in our case, we're just gonna bake it in. So one solution is we're just gonna preload the model. So what that means is that I have this script here that I'm gonna run during the Docker build, and it's just gonna download the model beforehand. Okay. And I will have an improved Docker file where I give the command outside in the instructions. I'm going to just copy over this preload script and I'm just going to run this script so that the model files itself is already baked into the image, right? And I'm going to like build it. And what's going to happen is, okay, so like, is that then the next time we do this, so if I were to build from this preloaded image, right, the you will realize that the model doesn't need to download, and the first inference that you make is going to be like as fast as all the other inferences for the most part. And you notice that there's also a specific order in which we layer. So the cache is done like the layer caching is done like from top to bottom. So if a layer hasn't changed, it'll be like skipped by Docker. Uh, so the thing is that you want to be careful in how you organize your layers because preferably what you want to do is that you want the things that rarely change, like your dependencies or like certain scripts, whatever, right? Things that don't often change to be at the top so that they're always cached. Whereas things that always change all the time, like for example, your code, they should be one of the bottom layers so that when if I move this, like say I copy this to the top, right? What's gonna happen is every time I change the code, right, I got to rerun all of these previous steps. But it doesn't make sense to, let's say, reinstall the dependencies if the dependencies never change, right? So we want to make sure that things that like change more often are at like the bottom of your Docker file. And this will like basically it's more for optimization sake, basically. Yeah, because there are some like Docker builds that really are gonna take like 10 minutes. Trust me, I've seen like 20-minute builds before for like really big projects. Okay, so yeah, let's try this. It's fine. So, but basically it's like this is what we've seen, which is that we build a thing and we can send requests, right? Okay, but let's go ahead and like cover like how we can actually go ahead and deploy these containers, right? So there are platforms as a service like Render, which allows us to deploy and host applications, including container. The alternative as well, like Google Cloud Run and like Cloudflare containers. Reason why I pick Render, honestly, is because like they are one of the few platforms nowadays that has like a free tier. Like there used to be platforms like Heroku that have free tiers that allow you to easily deploy containers, but unfortunately, like in this like modern age, we are very compute constrained. So a lot of like initiatification of services and stuff, meaning that we are going to use Render for this, but there's also alternatives like Google Cloud Run. Because if you use Google Cloud, I think the first time you use, they offer like $300 in free credit. Uh, which yeah, but we're just gonna demo with uh Render. And next is registry. So I mentioned before, basically registries are places where you can share your images. But the thing is that pushing image to a registry is like a bit more complicated because you have to make a Docker account, then you have to like run commands to authenticate yourselves, which we don't really have the time for. So what we're gonna do is we're just gonna let Render like handle the building of the image. So what's going to happen? Well, let's go to render. We're going to go to render.com. Let's see. Let me just pull everything. Yeah. Okay. So go to render, and let's say we made an account, and this is like the hobby like free tier basically. And I already have like something deployed. So this is going to be the end state basically. The end state is going to be something that's deployed and you have like a URL or something that you notice that what happens is it's waking up because render will automatically spin down your instance after it's been active for like certain like I think like 15 minutes or so. This is one of like the drawbacks, and this is what we call a cold start problem, where if a user hasn't used the service for a long time and you're using some sort of deployment service that auto scale from zero, their first request is going to take like a long time. And that's kind of that. So like in actual like production case, you probably set like min instance to one so that it's like always online. Um, but this is like the end product. So we're gonna show like how we can deploy and render. So I'm gonna click on new service and we're gonna create a new web service over here. And what we can do is that we can either build an image from a Git repository, or if we had some alternative flow where we already built an image, I already have an image on Docker Hub, for example, I can just tell you the name of the image and build from there. But in this case, we're going to connect to our repository, uh, and we're going to go and select the language as Docker and what branch. So this is sort of like can think of like a CI/CD workflow, right? So like what branch we're going to run on. So anytime I push to this branch, then I go set a root directory. So in this case, it's going to be like part two apps vibe search. And the path to the Docker file, which is, yeah, let me see. Yeah, instance type on that. Yeah, so this is okay, really annoying. Yeah. Then basically what we can do is that then we can also configure environment variables that are available. So in this case, right, for our app itself, um, I'm going to like define basically like a API key, basically as the environment variable. So I have this like vibe search API key, which I'm gonna like copy over. Or actually I can just like, yeah, I can just like copy everything from here. Uh yeah, and just add the variables, for example. And then I can click on deploy. Oops. And there are like also more advanced settings that by right we can configure. And I don't know why render is like hiding the settings for me. But you you should be able to set like let's say deploy. And it's gonna build the thing. But I'll just show the one that's already deployed to show like the settings and all that. But basically you can configure uh things like the Docker file path as well as like right now it's just set so that it auto deploys on any commit to main. But you can also configure this so that it will look at your GitHub actions test, and if the test fail, it's not going to deploy, for example. Right? Yeah. Okay. But let's just use the one because it's gonna take a while to build. Basically, it's gonna basically do a Docker build and then like deploy on a website that we can access by URL. So let's go back to our site first. Yeah. Okay, let's see. Right. So a few things that I'll need to run. Actually, I've already run these commands, but basically, we're gonna add like some protection to the endpoint. Because this currently is available to anyone. So like straight up, if you went to like this URL, you just like snipe the URL for me, right? You can just call my API, you can like spam call the API, which is not what we really want. So my intent is to basically try and protect it. So we're going to put like an API key so that you can only like call a service and like execute the endpoint if you have the API key available. But we want our main web app to actually be able to connect to it. So because the main web is running on Cloudflare, uh, I'm going to give you like the secret basically. I'm going to tell you what URL to call, and basically like what API key to run. In this case, like I've already like run this command, and so for sake of time, like we're just gonna like go to the next step. And also within the code itself for the Cloudflare worker, I'm gonna tell you that okay, you have access to this, and we're gonna like add a new route which allows Cloudflare worker to basically call our API, right? So given the environment of the API key and all that, you can send a request, authenticated request to this Vibe Search API and then get the response, which we will use in the app, right? And then we'll deploy it. So I mentioned before that this is one way. So one way to like protect is to use some API key or whatever, and then get fast API to check the API key and then like reject if it's wrong. Because right now this is public, right? So if like hacker like finds your API and then you just start spamming it, okay, this is a free tier, so we won't lose money. But like if you connect to a paid account, you might lose money. There are other ways if you want to go like fully integrated and you deploy everything on render, you can set like a private like make this a private service so that only your backend can call this, but only like containers on the same like so-called like private network can call each other. So that's one way to protect, but that requires that you kind of have everything deployed in the same place. So in this case, everything deployed in render or everything deployed on Cloudflare, like you use like Cloudflare containers and so on. Another way are things like API gateway. So like for example, like Google Cloud has a API gateway, or I think Cloudflare as well have API gateway, which means that you send all your network requests right through this gateway that has handles authentication and everything for you. But this we'll just go through like the simple way is just a set up API key, right? So what we're going to do is that in Fast API, we actually have configured this dependency, which will just check, right, that we have an API key before we allow a request to go through, basically. This is something that I already done beforehand, but it's one way in which you can go ahead and like protect your requests. Yeah. Okay. Any questions thus far? Sorry, like from the chat. I think like if any questions, just send in the chat and like Pat can answer them because I can't see the Zoom chat at the moment. Let me find out. Uh, yeah. Okay. So this is like okay, right? We have the setup here basically for deploying like running Docker containers, but in your local like dev environment, now you have like different services. You have things like your Cloudflare worker, which you can like run dev and all that. But as you add on more containers, right? Like you realize that if you want to test your Docker container locally or whatever, right? If you have like a bunch of services, because like things that are common that you use for Docker with things like databases. Like if I want to run a local database, instead of like installing everything manually, I will usually just pull a Docker container. Or if I want like let's say a Redis, I Redis add like a cache or Midnight.io to add like S3 storage or all that, right? It's going to be very annoying for me to manually do the Docker run commands and everything. So Docker provides something for local development called Docker Compose. And it basically lets us define and run multiple containers with a single command. So in this case, we have this what we call a Docker Compose YAML file. And basically it defines like what services. It is like a definition of, okay, I'm going to have like, for example, my byte search service, and I'm also going to have like a Postgres instance. I'm going to pull. And I can define that I can load from a pre-built image, or I can say that, oh, we're going to build from this directory, right? And I can define like certain things as well. So I can define like the port number. Uh, like when I did a Docker run, I did like /p 8000. This is basically the equivalent of that. I can define things like environment variables, which can also be loaded from a .env file. Uh, and I can define what I call volume. So I mentioned earlier that the data that is stored in the Docker container when it's running, right, it's not persisted. Right? Once I exit, I go back, the data that I added after the Docker container runs is lost, but I can actually persist it. So I can create what I call a Docker volume. Right? And I can mount like I can say that, oh, like in the Docker container, like any changes to this specific folder, like var lib PostgreSQL data, is going to be persisted in this Docker volume. So that when I restart the container, well, at least the data here, in this case, the database data is persisted. Right? And also, Docker also gives us networking. So what it means that if I want to call, let's say if I have two services that I want to call each other from, uh, normally networking like we do like especially like for internet development can be a bit annoying, right? Like you have to like find out like what's the IP or whatever to call it. If you are just doing inter-service communication and they're in the same Docker Compose instance, it sets up a Docker network for us, which allows us to basically call other services in the same compose file by their name. So I can call like Postgres like 5432 instead of having to type in like the IP address, which like is a bit annoying. So like let's say if I go here, uh and I go apps, uh let's see, do I have the Docker Compose file? Uh okay, it is in the previous wait, sorry. Okay, it doesn't wait, let me just yeah, sorry, my bad. Okay. Uh yeah, you have a Docker Compose file here. So I can run Docker Compose up. And this will, you notice that it's pulling the image automatically, the Postgres image, and it's just going to like basically do it all the things. So like if you have some complicated Docker setup, I would recommend that you can set up a Docker Compose file. Uh, but for exact syntax, really recommend you read the condition because there's a lot of different settings you can set up. Yeah, in this case, because I already have something running on port 8000, so which is my existing Docker container. So in this case, like the thing failed. I'll just stop it, but it's fine for the demo here. Yeah. Okay, so the cases in which we use Docker Compose would be mainly local development. But like if you have your like your own server, like you rented like a server like EC2 instance, uh you can also just deploy your app using Docker Compose, just like use it to start a Docker containers. I have a home server and like frankly that's honestly what I do to like self-host certain things because like anything like more complex than that is like a bit overkill. But in a production environment, usually like you will use some managed service, like in this case like Render or Google Cloud Run or AWS Fargate, or like you use like uh Kubernetes and that sort of thing to which will help you do things like ensure that reliability of your app. So that means that as the number of users that are pinging, like calling your app increases, right? These managed services can do things like auto scaling. They can scale up the number of containers and like load balance between them so that your one container doesn't get overwhelmed with too many requests. And it allows things like high availability. Like if one container goes down, you can start other containers so that your app is always available. Which Docker Compose like uh they can't really provide this thing that well. So it's more for local development. It's not really something you use if you need something that's reliable. Okay, so oh boy, not this again. My bad. Okay, so like this is like the last thing, which is on telemetry. This is something that I mentioned like last week. It was something that we would cover if we have time. So we got like 6 minutes. So I will just like briefly like cover because I also don't want to like waste your time. But this is something that you can actually add. So after we deploy our application, right, you may have cases where there's a bug in production, right? Your user uses an app and they tell you that, oh man, the thing crashed when I do this and this, right? And the thing is that like how do you like then trace like what actually happened? You know, when one user uses and they report that there's a bug, right? Like what was the actual underlying cause? And okay, one way is I can just look at the logs, right? If I go to render, I go to render, like I can look at like the logs for service, right? But the thing is that like you don't really like want to be like scrolling through like hundreds or different logs because a lot of these can be useless. It can just be like every like 5 seconds it's like pinging like the health check or whatever, right? So that's where you could just like add print statements or whatever. But that's really like manual. So we have things like monitoring and telemetry tools that help us to trace what's happening in the application when there are errors. Uh, so like we have tools like Sentry and Posthoc, and we'll be going through like roughly like brief introduction to Sentry. But if you're, let's say, right, your Orbital project, you're building some like agent application, one tool that I've used quite a bit before is called LangFuse, and that actually allows you to trace all of the individual like OpenAI API calls, and like if you have an agent, you can like trace like the entirety of like an agent's flow, like what tools it calls and all that. But that's a bit out of scope. So it's just something that exists. If you want to set up telemetry for your agents, but let's say you just have a normal app today, right? So Sentry help is something that can integrate within your app that can capture errors automatically. So like in your production app, and then sending emails and like stack traces and all that, like when that error occurs, and gives you like additional context of like which request caused the error, like what part of the code did it fail at, and give you like performance data to help you to debug. Right, so this is just an interactive like tutorial. But what we're going to do is that we're going to go to like Sentry. Uh, and basically what we will create on like the basically like a bunch of projects. So we'll create like separate projects for our Cloudflare worker as well as our Vibe as our fast API endpoint, right? And uh, what they will provide is that for these, right, they will actually give us what we call a DSN. So let me see whether I can find uh the DSN for this. I mean, I have it saved, but yeah, okay, SDK setup. So under the project settings, you'll find what we call a DSN. This is the URL that you put in your environment variable, which will because you will set up code in your code base, that will set up the Sentry client that will basically like trace your code and all that. Wait, sorry. My God, why is it? Sorry, my OBS is a bit messed up. Yeah, you'll see this DSN. Um, and this is something that you'll basically copy into your code base and copy into your environment variable, basically. Uh, and this will tell the SDK, the basically your code integration, like which project to send all of the things that is all the data that is collecting about crushing everything to. So in this case, for example, for Fast API, they have Sentry SDK, which will like initialize, and this will attach to your Fast API application and like just like track any errors and stuff. Uh, and we have to configure basically when you deploy. Let's say I go on render, right? I got this Sentry OSN. I will basically like DSN, I will copy it and I will paste it as an environment variable, which I already did when I set up the project. Um, and do the same thing for Cloudflare workers as well, because they have like different integration. Like say for Hono, they have a middleware that we can add that will basically let us track everything, all the requests that are sent over here. So I'm just gonna like keep it like long story short. But basically we set up the secrets, just tell you like what DSN, so that when we deploy, uh I'm just gonna show you like what issues. So I have an endpoint that uh called debug sentry, which just throws an error basically. Right. So like if I call the endpoint, it'll just throw an error, but this error will show up under my issue feed over here. So it'll be a runtime error. And I can actually see like what's happening at the time, right? So in this case, like, oh, what's the part of the code that caused error? What's the trace? What's like the request that was made, right? So you see the get request to this endpoint, like what happened, like where did the error occur? You can get more context. You can see like, oh, what is the part of the code base that might be the reason. So in this case, it identified that, oh, right, I got this like bug. In this case, of course, it's intentional. But this allows us to trace things happening in production because obviously it's running like locally, it's very easy for you to test. The problem comes when you have your user and they report a bug, right? Then like you might not even know like what is the time that they encounter this bug. So you don't even know like when the logs to check or for like what error occurred. And so like these tools like help you to diagnose production issues basically more easily. Uh, yeah. So like let's go back to the slides. But yeah, I'm gonna like skip through. Basically, here is just like we were intentionally introducing a bug and then like seeing like the stack trace and then like debugging like what actually went wrong. But because we are a bit short on time, we're just gonna like skip to basically the end. So this is like sort of the end of the workshop. I had like additional content after this if we had like spare time, but since it's already 12, we're sort of like uh in a way like end off like and here. So basically in the part one, we have in part one, we manually deployed application on Cloudflare workers and set up Superbase integration. And in the part two, what we have done is that we have added things like unit tests, we have added end-to-end tests with V-test and Playwright. We have set up CI/CD workflows with GitHub actions and set up containerized services that are deployed on platforms like Render, uh, and introduce things like telemetry logging and stuff. Yeah. And so that would be like the rough end of like the workshop. So I think if you have any questions, like do ask. If you want to like stay on, like got any questions, like we can answer and stuff. Sorry. I need to find like where is the chat? I can't see the chat actually. Yeah. Yeah. So okay. All right. I think we can end the recording.
Yep.